Hi, it's dumpster diving time again, but these ones didn't come from my dumpster, these come from a university dumpster, in particular the University of Technology here in Sydney, my old stomping ground back when it was like just the big ugly old brown building anyway, and now it's all fancy pantsy. They were throwing out these gorgeous things, and thank you very much to Jared. Here's a photo, he just delivered them to me, he rescued them from the UTS dumpster. So what we've got here, oh look at this, I've always wanted one, the BWD 603B Mini Lab. BWD, an Australian company, BWD Instruments, and they manufactured oscilloscopes. The BWD Power Scope was an isolated oscilloscope, and it was hugely popular back in the day. Hands up if it ever made it overseas. It was like massive here in Australia. Anyway, yeah, BWD, and they manufactured this mini lab. And if you studied electronics at university or college here in Australia, there's no doubt your lab would have been filled with these BWD 603 mini labs, and they were just absolutely fantastic. And there's lots of nostalgia for these here in Australia, and the second-hand market for these was huge for a long time. I don't know if it still is, but there's a lot of people who swear by these BWD mini labs, and I used to use these back in the day as well. So we've got a function generator with a beautiful dial here. It's only 200 kilohertz. Yeah, 200 kilohertz bandwidth. Looks like you can do some modulation here. I totally forget, it's been so long. And they had a operational amplifier here, and you could adjust the gain of your operational amplifier here. And then they had a power amplifier, which was pretty cool. So you feed your input signal, and you could adjust the bipolar power supply on it, so plus minus 15 volts at 1 amp. So you could actually power things like a power amplifier. It was fantastic. Then we've got our regulated power supply over here. You dial that in, positive and negative jobbies. And then over here you've got an AC power supply, 6.3 volts AC for your valves, of course, your tubes. And then you've got a high voltage power supply, DC power supply up to 200 volts here. And this was great for, like educational lab experiments and stuff like that. It was the duck's guts. I can't believe I finally got one. I've never torn one down though, because it's not like in the labs I could just like tear it down. So yeah, curious to see inside. But I might have been more excited to get this one, the Kikusui 5040. This was actually my first oscilloscope. Wasn't this model? Mine was the 5020, the 20 megahertz model. This is the 40 megahertz model. But then once it got here, I looked at it and I went, digital storage oscilloscope. It's got storage modes. It's got a storage mode. I had no idea that Kikusui manufactured a digital storage version of the 50, like the 5000 series. So it's the DSS5040. I had no idea it actually existed. Of course, these sorts of analog digital combi scopes were common back in the day, but I didn't know Kikusui did one in this series. So that's absolutely fantastic. I assume it's the standard 5040 model, which I couldn't afford back in the day. My 5020 model I got from David Reed Electronics cost me about $800, I think, back when I was a teenager. So, saved up all my money. That was a huge thing for me back in the day. It was my first oscilloscope. I don't know when I sold it. I still don't probably after I upgraded to the Kikusui COS 6100M, which is a 12 trace oscilloscope. I'll put up a photo of that bad boy. I think I sold my 5020 when I upgraded to that one. That was 100 megahertz bandwidth, and you can do like 12 traces on it. Absolutely incredible analog scope. But yeah, anyway, digital storage oscilloscope. I don't know the specs, haven't looked it up. It's a little bit dirty, so I might do do some spit and polish on it before I try and power this thing up here. Might even do a quick teardown before I power it up, just to see what's inside. So let's go. It's been banged up a little bit here, and as you can see, it's a bit crusty. She's been sitting out in the, well, oh yeah, we've got some genuine cobwebs there. But Kikusui, made in Japan. All the best stuff's made in Japan. Thank you very much. It's got the pen pen plotter output, so you can actually get a plot output of this thing if you want to like feed it into like a chart recorder thing or something. You'll notice how it's got like the classic yellow and brown kind of color scheme that was common back in the day. Jared was saying he's surprised it doesn't have like wood paneling like surrounding it. I think that's hilarious. Anyway, the B&Cs look a little bit crusty, but physically they seem okay. So odds of this thing still working pretty good. I'm pretty sure you can get the service manual for this thing with all the full schematics and everything. But yeah, this is not a dual time-based version. I thought the 5040 was a dual, like the analog version of the 5040 was a dual time base. Maybe it's not. My memory might be a bit rusty on that, but couldn't afford the 5040. All I could afford was a 20 meg scope. And the interesting thing about oscilloscopes, I've mentioned this quite a few times in the past, is that basically 800 Aussie bucks has always been like the sort of introductory oscilloscope price here. And it's as true today as it was back then. You can get a hell of a lot more crow these days. It's a crow here in Australia. Thank you very much. Cathode ray oscilloscope. Crow. And people will still call digital scopes crows. Hand me the crow, you know, when it's a newfangled digital thing. Anyway, yeah, the price point hasn't really changed over, like, what, 40 years? It's pretty crazy. So the switches feel pretty nice. The verniers, they feel pretty good. They all click in place, all feels nice. Give them a few rotations to clean the contacts, and I think Bob's your uncle. So I think the odds of this working pretty high. I'm curious to see what the how the digital storage section works on this thing, because I had no idea it had it. Do not use. Well, I think we're going to use it. It's got the old school feet on it that you can wind the power cord around the back. Beautiful. Well, you know what we say here on the EEVblog, don't turn it on, take it apart. Come out of there, come on. Whoop, hit the fail button. Well, that wasn't a fail, that was a winner-winner chicken dinner. Well, this actually looks pretty decent. I don't even think it's going to need a blowjob. Of course, these things don't have fans, so there's no airflow through these, so you're not going to get all that, you know, usual horrible dust build up and stuff, so it looks pretty nice. And there's something you don't ordinarily see in an analog oscilloscope, because this is a combi scope, both analog, true analog, and digital as well. You have to actually swap the modes, and you don't normally see all this 7400 series digital stuff tied into the analog video circuitry, but that's what we've got here, because it's actually got to put the digital information on the display and maybe some text information as well, perhaps. I don't know if that's advanced. Haven't even read the manual on this thing, seen any photos of it turned on, so I don't know what you're actually going to get on the screen with this thing. But yeah, that is the display PCB, and it looks in pretty good nick. No worries. Bottom side here, we've got our main processor board, and that goes up to that display board, which is right angle there. And then this is a little bit dusty. So, yeah, a little bit of dust on there, but not too bad. So this is the main oscilloscope analog front end. So here's our inputs here, and yeah, this is just all the front end amplifiers, and there'll be horizontal and triggering and everything else on there. And then up the top, we've got, sorry, I'm not going to take this apart completely, but up the top, up under there, we have our sweep PCB. So, you know, that's going up to the controls on the top, which are, of course, your sweep mode controls. This one doesn't have a delayed sweep on it, so it's not that advanced as far as, it's not a dual time-based delayed sweep. So, as far as analog scopes go, yeah, it's not that advanced. It's just basically the same 20 megahertz one I had, except 40 megahertz bandwidth, and with a digital sampling add-on system. Now, I have really no idea what's going on with this crusty stuff. This is like a rubber cable, and yeah, I'm not sure what that is. Bueller? Anyone know? Leave it in the comments. Can barely get the processor down in there. It's a sharp jobby. That's about all I can make out. There's a ROM next to it and a couple of SRAMs below it. Anyway, those mains filter caps still look good. These would be Japanese, of course. I can't see who makes them, and that'll be on the other side, but Kikusui, of course, Japanese company, hence why they're using a sharp processor in there as well. So yeah, lots of Japanese parts in this. So I'm fairly confident to power this thing up. It's not like I'm going to go into a direct capacitor replacement or anything. You know, confidence is high. I repeat, confidence is high.
Confidence is high. I repeat, confidence is high.
But not that high that I'd do it in the lab here, just in case it releases the magic smoke. I might go down to the dungeon. And you don't see those old school voltage selection plugs anymore, so we'll put it on, it was on D, we'll leave it on D there, 207 to 250 volts. Wow, it's powered up. Okay, down in the dungeon, fingers crossed, will this thing, it probably hasn't been powered up in 20 plus years, would be my guess. So yeah, here we go. All right, so mains power on, and it does have a fuse in the back. I did check it. So let's go. No Bangsky. That's good. Oh yeah. There's a cow. There's green cow LED over there. Don't know if you're seeing that, but intensity. I see the graticule light, the illumination there. The pot's a bit dodgy, but. Whoa, hello? That was a trace. Storage mode? Oh, storage mode. Look at that. Okay. We have some form of sweep. So, coupling, internal, auto. There we go. Winner, chicken dinner. So what happens is at 1 millisecond per division or higher, it's in chop mode there. So what that does is it just like literally chops between channel 1 and displaying channel 1 and channel 2 like that, because the time base is too slow, and if you swept it, you would be seeing like it'd draw channel 1, then it'd draw channel 2, and it'd be really annoying to compare waveforms. So what it does is when you go to a faster sweep time, i.e. 500 microseconds per division or faster, it will go into alternate mode, which alternates between channel 1 and channel 2. So an entire sweep like this will display it'll display channel 1, then display channel 2, and that's happening fast enough so that you can see that. Anyway, dual channel, there we go, there's our dual sweeps. We're getting the time base. You're seeing that. Trust me, that's going really fast, but we're beating with the frame rate of the camera at the moment, so that's why you're seeing that. So there you go. So you can see the alternating pattern on that. It alternates between the two waveforms, and that one is going choppity chop. But anyway, that is a winner chicken dinner. I had no doubt. Confidence was high. So we can adjust our focus there, because that line's a bit thick. Oh, look at that. Oh, that's thin as. That's beautiful. Beautiful. The intensity is fantastic. Looks like we have a winner chicken dinner here. That's a graticule illumination. You're probably not... Oh, yeah, you barely see that. And how's our vertical? It's a bit noisy, it's a bit touchy, so you want to get in there and clean up the contacts on that. Just squirt some contact cleaner in there, and Bob's your uncle. Let's go right down. We're at 5 millivolts per division. It's got ×5 magnification, so we'll pull that. Whoa! Hello! We have some ripply doodah there. Do we get that on channel 2? Yeah, channel 2's all the way down. So... And their range is, yep, perfect. There's no issues there. And that is ×5 mag. So that's ×5 mag. So we're getting that ripple on channel 1 that we don't get on channel 2. So, I don't know, design shielding issue on channel 1. I find that hard to believe. I think there might be, I don't know, some aging in some cap somewhere there. But on 5 millivolts per division, it's absolutely perfect. So it's only on that ×5 magnifier circuit. So if you wanted to fix that, you could narrow, if you got the schematic, you can narrow that down to the ×5 amplifier. Yeah, we're not going to see that on the higher settings. So yeah, it's only on the lower, absolute lowest setting that we have an issue there. So that seems to be the only problem so far. Position control works fine. All right, I might take this back up to the lab and we can feed a signal into it. There we go, we feed in the calibration signal and that is bang on. That is no problem whatsoever. Can we, yeah, well, yep, we can magnify that. There you go, that's ×10 mag. That works just fine. Go into XY mode. Yeah, we could play with that later maybe. But let's go into, okay, normal trigger, single shot trigger. Boom, 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 boom. So that's working a treat. Positive, negative slope, coupling, HF reject. Well, it's not going to do anything. TV is not going to do anything. It's got no TV sync, DC. That all seems to work fine. Line, yeah, we expect it to wander like that because it's trying to, it's synchronizing to the line frequency, i.e. 50 hertz here in Australia, none of that 60 hertz rubbish. External, you wouldn't expect anything because no external trigger. So, that is beautiful. Channel 1 is just fine. Just a bit of a dodgy switch there, but you come good once you clean the contacts in that. No worries. AC coupling, look at that. Ground, oh, oh, oh. What was that? What's that? Whoop. Woo. Yeah, channel 1 has a little bit of an issue there, but generally it works just fine. How about channel 2? And channel 2 is also a winner chicken dinner. AC, DC, position, yeah. Yeah, that's great. That switch is in better nick than the other one. No problems. Got our hold off control here. Well, and we can click that in place, no worries. Yeah, I deem that to be, apart from the channel 1 dodgy switch, that is in perfect working condition. No worries. Now, this mysterious digital storage mode, I still haven't looked up any of the specs on this. Usually scopes of this era, if it's 20 meg samples per second, I'd be surprised it could be 10 or even 5 meg samples per second, something like that. So yeah, and the memory size, you know, like a K, 2K maybe if you're lucky, and it's got a view time control and trigger point division. So let's switch it on. Then we've got sine or pulse. Pulse? I was going to say that's like interpolation, but what's going on there? We can save the waveform. We can store a reference, which is great. And then we've got the pen mode. That was the output connections on the back, so you can actually get a printout on a pen plotter. Hence why it's pen, good old school pen plotter of the stored waveform. Cool. So let's go into storage mode. And looks, whoa, oh, there we go. It was getting pre-trigger information, was it? There you go. And notice, take a close look at the waveform, okay? When we go, right, we're analog, like it looks analog-y, okay? But when we go into storage mode, watch this. You start seeing all the little bits in there, right? This is the 8-bit ADC sampling resolution. So storage mode works just fine. So what does, yeah, sine, that's pulse and sine. So it's, yeah, it's changing the interpolation there. That's what that's doing. So can we zoom in? So we can zoom in on that bad boy, and maybe if we go, no, sine, and that's the interpolation, that's the sine interpolation, is it? Anyway, it's not updating, it's updating what, once every couple of seconds? And there we go, view time. That is, if I turn that over there, we're updating, you know, what, 3-4 times a second there, and then we slow that down. So we're getting, that'd be trading off memory for sample rate, for update rate. So that is cool bananas, is it not? That's great. So storage mode, and we can go save. Boom. We just saved that waveform, and then can we go back out? No, because we're just going to go back to analog. Come back in. No, we've just captured that waveform basically. So can we single shot capture that? We can. Boom, boom. I am pressing the boom button there. There you go. Single shot capturing. Beautiful. And then pen, we can go save. Like, well, yeah, save. And then we can go pen and boom. It's outputting that information there to the pen output. Nice. And the trigger point division there, it's just like the trigger point is going to be the second division. So it looks like that's our trigger point there. So division 2, division 5. So 1, 2, 3, 4, 5 right in the middle. Positive, negative going like that, and or you could shift it over to division 8. So you're basically getting more pre-trigger data there than post-trigger, or if you go down to 2, you're getting more post-trigger data than pre-trigger. But it looks like there's no way to go down to 0 to get 100% pre or post-triggering, but acceptable compromise for the era. Well, I was right. Here are the specs for this thing. Yes, maximum of 25 meg samples per second with 1024 points sample memory. So 1K of sample memory, but that's all you need for on the display like this. It's just fine, and this would have been extremely useful back in the day. I didn't have one. I only had the analog jobby. So yeah, I would have lusted after this. I didn't even know that they made a digital version of this. The analog version is the COS5040, which I did find a schematic for, so you can actually get the schematic for it, which would be identical to this. All the analog front end would be absolutely identical. Don't know if you get the schematic or the service manual for the this DSS digital storage version, but anyway, it works absolutely fantastically for all these decades later. What? You know, this is a 40-year-old oscilloscope. So anyway, I hope you liked that and found it interesting. If you did, please give it a big thumbs up. And as always, you can discuss down below. And yes, I will actually leave the BWD Mini Lab teardown for a separate video. This one's long enough, I think. But, what a beautiful scope. Kikusui, one of my favorites. It was my first scope, the COS5040. Oh, I remember picking that up. Seemed like yesterday. Fantastic. Catch you next time.